Hi, welcome. Thanks for watching this video. This is going to be an example for the capacitor and first order solution. So we're going to look over this circuit, which we want to find both the voltage across the, wrong one, capacitor. So we want to find both the voltage across the capacitor and then also the current through that 3K resistor. And so to start this, we're going to begin by looking at the time right before a change happens. And so in this instant, the change happens at 0 and it moves from position 1 to position 2, as it states in the description. So with that, it's going to start in position 1, so it will have sat there a long time right before that change happens. The capacitor will be an open here, and we want to find the voltage difference between the left node and the right node. So in the left node, we're going to find this voltage, and then we're going to subtract off the voltage in this node. So we need to find each of those nodes, and then the voltage V is going to equal, I'll call this V1 and this V2. So it's going to be equal to V1 minus V2. So to start with, let's find V1. So to find V1, we can do a node voltage at that node. So 2 milliamps is going out, and then V1 over 4K equals 0. So I define this as V1 over 4K. And solving this, we get V1 is equal to a minus 2 milli, and then times 4, so a minus 8 volts. So this one will be a minus 8 volts. Then we need to find the voltage at V2, and so V2 minus 18 over 4K is going to be the current in this branch. So V2 minus 18 over 4K. And in this branch, it's going to be V2 over 3K plus 4K, or 3K plus 1K for a value of 4K. So V2 over 4K equals 0. And then we are going to combine the numbers for the variables for V2. And we take over the 18 over 4K. And then we can divide by this 1 over 4K. And this one ends up being 2K. A plus 9 volts. So this value here is going to be plus 9 volts. And then V1, which is a minus 8 minus 9, is going to be minus 17 volts. So we get a minus 17 volts here for V. And so this means that when the switch happens, that voltage has to stay the same. So we are going to put the voltage plus to minus, a minus 17 volts. And now in this step, we have, this is our initial value step. So we are going to find both initial values of the current here, which was I1, and we're going to find the voltage here, which is going to be the same here, so we don't have to do any steps to find this minus 17. That's going to be our initial values. So we have, this is the initial value for this one, and then finding I1. I1 here is going to be this voltage, which we already know is minus 17 volts. So I1 is going to equal minus 17 over 4K. Well, let me take that back. It's a minus 17 for a plus 17. So this node is, highlight it. So this node, the value of the battery is a plus to minus. So if we measured that node, that purple node, it would actually measure a minus 17 to give us a plus 17 there. So this is going to be our value for I1 for the initial value is 17, a plus 17 over 4K. For the final value, oh, and just note, if I had used before the switch even happened, which again, you want to conceptualize that these changes happen right before a time, you're using that to be able to get the value at what happens at the change itself. So if I had another change, say I switched back to the switch, I think it was 1. So started in 1, if I switched to 2, that's what I'm determining this equation. But if I switched back from 2 to 1, now it's sat at position 2 for a long time. Switching back to position 1 is going to actually change it again. And so I would use, again, what I'm trying to find for that final time of whatever that switch is. So if a switch is going on and off and on and off, you're going to have to find this expression for once it's changed in one position, and then again when it's changed in a different position. So if it's charging, discharging, charging, discharging, charging, discharging, or charging and then charging up to another voltage, and then it goes back down to a different voltage. Anyway, both of those changes will have different forms of the expression, the final expression. So if you have a switch going on, off, you're going to actually have to do this step, these 4 circuits twice for different time frames. Okay, so that was just a side step. So in this case, at the final value, it is in switch 2 position. This will have sat there a long time, so this becomes an open. And then the right side of this is 0 volts. So I just need to find the voltage on this side, which it may look tempting to use 18 volts, but remember 18 volts doesn't go all the way to ground. So there's voltage across that 4K. So we need to use node voltage here. And so I'll just call this V3. So we have V3 minus 18 over 4K plus V3 over 4K equals 0. And so combining these to give 1 over 4K, 18 over 4K, and then dividing by that 1 over 4K plus 1 over 4K gives me 4. The 4s are gonna, this turns into 2K, and so I end up with 9 volts here. So this voltage here is going to be 9 volts. And so V here, which is my final value, is going to equal minus 9 volts. Again, that's the polarity that's from ground to that node, and that node is 9 volts. And then I1, which is going to be here, is going to be 9 over 4K. And so these will be my final values for my expressions. So this is the final time frame. For tau, we want to find our equivalent that is seen at the final stage. So at the final stage is going to be this one, A to B here, and then we remove our sources. So removing the sources, the current source goes to an open, and the voltage source becomes a wire. And so here at B, to get back to ground, I'm going to have a split of both of these. So I have 4K in parallel with that 3 plus 1. So my RTH split is going to be 4K in parallel with 3K plus 1. To give me 1 over 4K plus 1 over 4K, which ends up being that 2 kilo ohm. So tau is 2K times C, which C, if you look back, was given as 2 millifarads. So this gives me 4 seconds. And now our expressions are going to be for t greater than or equal to 0, we have that VC of t, the voltage across the capacitor. We have the final value is a minus 9. The initial value is a minus 17. So a minus 9, e to the minus t over 4 seconds in volts. And for I1, green, I1 of t, the final was the 9 over 4K plus 9 over 4K, and then a plus 17 over 4K minus 9 over 4K, e to the minus t over 4 seconds. So these will be our final value expressions. And for the exam, I could possibly ask you for a specific time period t, not time period, but for a value for t to plug that in. And so you would then have to plug in this value for t here and then get a numeric expression. All right, thank you for watching, and let me know if you have any questions.